Hello, so today we are going to look at a couple of sorting functions in Kotlin and see which one to use when and how useful they are, okay? So the simplest case for sorting in Kotlin is to just take a list, right? And just convert it to a sorted list, right? So this will create this sorted one. And so let's just run it and see what we get. Sorry, I need to uncomment. And now if we run it, we see that we get the list sorted. So pretty straightforward. You could do it also on strings. You could do it on integers. You can basically do it on anything that implements comparable, on any class that implements comparable. And so if we run it again, and you can see here with letters, we get the uppercase ones first, the empty string first, and then the letters themselves are in order, okay? Okay, so that's just the simplest case. Now, what if we have a list of cars, right? And we have for each car data class that has a model, a maker, and speed, right? So, and then we have 3 of them here, each with different values. So if we want to sort these, let's say by the model, just the model name string, then you could actually just pass in a selector. So sorted by takes in a selector, and that selector gets as a parameter the type of in the collection or in the iterable itself, which makes sense. And then it returns a new result. And that result is basically what will be used to compare, okay? And so if we take a look here, what do we want to compare it by? By the model. So we just pass a selector that selects the model. If we wanted to compare it by the maker, we just do it like this. If we wanted to compare it by speed, we do this, right? And if we print, let's just print this for these cars. So we expect to have the models sorted in alphabetical order, and that's exactly what we have, right? It happens that they are already sorted, but if we just mix this order up, you can see we have A3 first, Ford F-150, and then Toyota, right? So the right alphabetical order, even though it wasn't the right order here, okay? Okay, so now to go into something a little bit more interesting, let's take two lists of integers, right? And let's try to zip them, but we want to get a list of pairs of these two, the values from the two list, but we want to sort by the second list, right? And so the first part where we get the pairs is just zipping the first one with the second one, and then sorted by, again, we can give a selector, and this selector would be based on the result of zip, and zip gives us a list of pairs. And so to get the second one, we just go to second, right? So that's exactly what we use here. Now, we want it to be, let's say, decreasing order of the second, then you could use reversed, right? This one just reversed the list, okay? And so if we run it, let's just print align this. We should expect to get the one with 33 first. And that's exactly what happens, right? So you can see they are sorted by the second parameter. Even though somehow these were sorted by increasing order, but actually if we make, let's say if we make this 7, right, you will see that it's not sorted. It's not sorted. The first list is not necessarily sorted in increasing order. So you can see here 7 is first, right? Because of this 33 is the biggest one, okay? Now this reversed is a little bit ugly, I think. So Kotlin also has a convenience function to sort in a descending order. Of course, these being numbers, you could just not use reversed and just sort by the negative value, right? That should work, but it's just more readable to have it explicitly say that we want descending by a specific value. And so to do that, you can just use sorted by descending, and you pass the selector, okay? And the selector can be an integer again, it can be any comparable, it can be a string, and it will be sorted in the descending order, okay? Okay, so that was, I think, a little bit on the simpler side. Now let's check another example here. So if we take a look, let's say here we have a player data class that has a name, an age, and then a score. Okay, and let's say I have a set of players here, each with a different age and each with a different score. So one way, maybe use case you can have in your applications or in your code is you want to have like more sophisticated sorting. So not just sorting by one criteria, but maybe by multiple. So for example, here, let's say we wanted to sort by score first. We wanted to sort the players by score first, and then if the scores are equal, we want to sort by age, and then if those are equal, we want to sort by name. Okay, so multiple criteria. Then again, you could use sort with, and sort with can be passed a comparator, right? And that comparator can have multiple nested comparisons. So for example, here we want to compare first by score, and then we can say call this then by, that will combine the previous compare with the new one. So you can see here it checks if the previous compare is different than 0, and this basically means that so if it's different than 0, then it just uses the previous compare. So different than 0 for the previous comparison means the values were not equal. Okay, so if they were not equal, then we want to just use the first comparison. But if they were equal, we use the second one. And you can keep nesting like this. This one also would use as the previous comparison the one with the age, right? So if the age is equal, it will use the name, right? And so this is a way to sort of nest them. And so let's run this one on these players. And you can see here, okay, let's comment the other prints just to make sure we get one result. Okay, so if we run this one, okay, you can see here, what do we expect as the highest score? Well, the highest score is, the smallest score, because this is increasing order. So the smallest score is 70, and then the second smallest is 80, but these two scores are equal, which means we need to compare by the age. And if we compare by the age, which one is smallest? It's Preston. So that's what we have next here. And then the second one is going to be Dan, because that's the next after 21 in the age. And then after that, the largest one, which is Ninja, right? With a score of 90. Okay, so you can see this one works. Now, this one is a little bit more cumbersome with compare by and then by and then by multiple times, right? So Kotlin also has a way where you can pass to sorted with, the same sorted with we called here. You could pass it multiple, you could pass it one compare by, but that compare by can be passed multiple selectors. So you can see compare by has as a var_arg parameter a set of selectors. So you can, for example, here, instead of passing them one by one, you can say you want to compare by first IT score, and by age then, and then by name, right? So if we run this, let's actually keep this just to see the difference. So you can see we get the same ordering, right? So it works the same way. Okay, so that's sorted with and passing a compare by. Let's say you wanted to do this, something similar to this, but more in a descending order, similar to what we did earlier here, where we had sorted by descending. Can we do this? This sort descending is more readable than doing something like minus or something like something similar. And so here we can do actually that. So we can go with, so we can sort players by descending order of scores first, and then if those are equal, by descending order of age, and then if those are equal, by descending order of name, right? And you can see actually what compare by descending does is just it gets two parameters A and B and just reverses them, right? That way, basically, let's say you had 1 and 2 and 1 was smaller than 2, right? If you pass them in the reverse order, you would pass 2 and 1, then you will get the reversed order, but you still can use the same comparator, right? So that's the clever part here. Yeah, so let's run it and see if we get them in descending order. And you can see here, that's exactly what happens. We have the first highest score, and then these two are equal, so we get the first highest age, and that's the idea. So this works fine. Now let's see. So how do can we simplify this one similar to what we did to simplify the one before it? Let's try a couple attempts. So we can pass a compare by, right? Similarly to what we did here, but we would have to call reverse it similar to what we did in the first example. Even though we won't do compare by descending, we'll just compare in ascending order and then reverse. So that's an alternative way to do it. But that's actually not nice, right? Doesn't read quite nice as this one. And so can we just have something like this, compare by descending, and not need this reverse? Well, unfortunately, Kotlin doesn't have that function. But Kotlin has extension functions for you to define on top of libraries your own use cases. And so we can define our own compare by descending that has the same behavior as compare by, where we can pass it a list of selectors. And so I have it here defined. So we just need to pass a list of selectors, right? And selectors are just anything that implements comparable we can compare by. And so that's what we have here. And then we can just use the same thing that we saw. So you remember when I checked the compare by descending here, let's say when we were here, when I checked this function, you can see what we did to change the comparison, reverse it, is just pass, basically reverse the parameters. So we can actually do that exact same logic here for our extension function. So we get BA, or maybe let's say we get AB, and we pass BA, okay? So this should work fine. And now we can pass a list of selectors. So here, compare values by for these two values, we pass the list of selectors that we want to use, okay? And this should work in the same way, so let's just run it and see. And you can see it does work fine. We get the highest score first, and then when the score are equal, we get the highest age first, and then we get the smallest score last, okay? So yeah, feel free to, if like you have a function where it doesn't read quite nice, like this one, you have code that doesn't read quite nice, and there is no library functions that exactly will make it read as you wish to, then feel free to create an extension function so that your code is more readable. Okay, so that's that. Now let's see a couple of other cases. So another neat thing is that you can also pass to your sorted function a reverse order comparable. And what this does basically is just, it takes the order that you would have if you just called sorted, right? So the natural order of that class, and that's usually what comparator implements for that specific type. And so whatever that order is, it just reverse it. And so, for example, here, these are numbers. So the default order is increasing. And so if we just pass reverse order here, then it will just take the natural order of that type and reverse it. Okay. So if we run this, we expect to see a decreasing list of numbers, right? So let's run it. Okay, let's remove these prints first. And you can see we get a list of decreasing numbers, okay? Now, one other, I think, good case often that you may use, especially like if you are getting data from the backend that you don't know may have like some null values. So for example, here we have a list of integers and null values, and we want these null values to either move them to the start of the list or to the end of the list. Let's say maybe it's these null values, you want to represent them with some, let's say in a UI, you want to display them with some default, but you want them to be at the end of the list. Some default layout, but you want it to be at the end of the list. In that case, you can use nils last here, which will just put all the values of null to the end of the array. You could also, if you prefer to do them, put them first, you could use null first. And this is just a comparable, right? And all this comparable does is, if the value is null, you can see here, if the first parameter is null, it puts it to the end. If the second parameter is null, it puts it to the front, right? This is null first, okay? And so so if you are comparing basically two values, those are the A and B's that are passed here, right? So this is the first value, and this one is the adjacent one to it. So if the first one is equal to null, then it puts it first. It says that it's smaller so that it gets put first. If the second one is null, then it says that that the comparison says that this one is smaller, and so this one gets put first. I hope that makes sense. And so yeah, this is a neat little function that you can use for null variables. And so if we print this for nulls first and for nulls last, let's see what happens. So you can see for nulls first, we get the nulls value first, and then for null last, we get them last. And yeah, I would recommend just going through the comparison class here or file for Kotlin, and then just do a review for all the functions that are here. They are pretty useful. Yeah, so I think that's pretty much it. That's what I wanted to cover for today. Please like and subscribe, and see you on the next one. Bye.